Welcome and thank you for joining our webinar today. Cybercriminal Checklist Review, Password Theft Tactics, and Pass the Hash Attacks. Whew, it's going to be a good one today, you guys. We're joined with hacker, enterprise security MVP, and named by SC Magazine as one of the top women to watch in security, Paula Januszkiewicz. You're also joined by Beyond Trust product manager Martin Kennard, who will run us through a brief overview and demo of Beyond Trust PowerBroker Password Safe after Paula's portion, so please stick around for that. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the chat box in the GoToMeeting console anytime throughout the webinar, and we will cover your questions at the end during our Q&A time. So anytime you have a question, just pop it on in, and I will be monitoring those throughout. Also, today's session is being recorded, and you will all receive a link to the recording and the slides shown here today within 1 to 2 business days from now. So now that that's all out of the way, I'd like to welcome Paula to the line. Hello, Paula. Welcome. I'm hoping that you'll do a little opera singing for us maybe today.
Well, if I will do that, probably amount of guys attending the webinar will decrease in half or something. So maybe not. But welcome everybody, and thank you for the very nice introduction. Let's start our webinar. As you see on the slide, my name is Paula J, and I'm the CEO of Secure. A couple of words about myself. It's always, of course, a pleasure to be a part of Beyond Trust webinars. Hopefully you're enjoying them too. It's not my first time, but if this is your first time, it's time for me to introduce myself. So as you see on the slide, well, having a little bit of a business role, I'm also a very technical person, so I do deliver penetration tests at the customer sites together with my team. My team has grown up for the past 10 years. Now it's 36, and we are placed in New York, Dubai, Switzerland, and in Poland. This is our HQs. And what do we do? Well, anything that is related with cybersecurity. And while we are discussing, of course, the passwords and all the different theft techniques or tactics, and pass the hash as one of the most famous attacks, we of course try to use our own tools, and that is something that we're going to be also discussing on this webinar. So couple of words. Well, basically I do have also a chance to an absolute pleasure to speak at the various conferences, including, for example, Black Hat, or including Microsoft Ignite or RSA, like last time in San Francisco. So I'm going to be there as well next year, this year, so 2018, very shortly, so hopefully see you there. And last year, 2 of my sessions were rated amongst top 5, so hopefully this year there's going to be something interesting for you too. And of course, if you want more about this, that's our email, info@secure.us, and this is a little bit of information of what we do, delivering trainings, high quality pen tests, etc. Let's get into our subject. So basically, whenever we are thinking about passwords, as always, we do have a session that is packed with different types of demonstrations, but it's important to understand how passwords are stored in the operating system and how we're able to extract them, because we could be thinking, of course, about the hashes at some point, but eventually that's not everything. It's just much, much more. And regarding a little bit of analogy, of course, sometimes we think that the password is kind of hard to get, but there are over 20 ways in Windows, by the way, to grab different types of passwords stored in various locations. And that's something, guys, that you need to know. Now, what's going to be my point is to guide you through all these different types of places where the password might be stored. And let me, of course, start with the first demonstration. Yes, so that's going to be the case. So whenever we are thinking about all the different types of juicy details for passwords, what is important to spot is how they are maintained, how they are stored within the operating system. And let's start with the obvious thing that probably we are all wondering about, which is related with storing hashes. And where are those, how we're able to grab them, etc. So this is something that I would love to show you. First of all, what we're going to do, and I'm going to switch to my virtual machine environment, we're going to dig into things like extracting the hashes from both ntds.dit as well, and also the SUM database. Let's start with a little bit of a challenge, which is going to be, of course, ntds.dit, and I would love to show you how we are able to perform this kind of activities, all right? So there are various ways of how we can do that, and this is something to, well, dig into. First of all, in order to be able to extract these hashes, you need to be, well, having some kind of a copy of, first of all, a system hive, and then, of course, ntds.dit. And the reason for that is very straightforward, because whenever we are discussing passwords, then, of course, we need to take into consideration that well, whatever we've got, whether if it's ntds.dit or if it's some database, both of those files, they are indirectly encrypted with something that we call a boot key. And boot key is stored within the system hive, and boot key, just for the reference, consists of a class names of a couple of keys within the registry, within the LSA part, and that's the, and let me show you how it works. And we're going to get into LSA, so that's quite straightforward. So we're going to get into system, as we already mentioned. We're going to pick a current control set, control, and then LSA. Here we go. And then, of course, when we are discussing the boot key thing, then this is something that is in data, JBG, JD, and SKU1. Yeah, so the class names, so you don't really see them over here. We've got an additional tool to display that, which I will show you, by the way, later on, but that is something that it's worth knowing. Yeah? So anytime you would like to decrypt something that is system-oriented, you always need to have a system hive for the boot key. So this is something to have a look at. We're going to also touch base during this webinar on the data protection API, so that you have a clear understanding of how the passwords are protected in the operating system as well. If you are a certain type of a user, and are they safe or not? Are we able to extract user secrets? That is all the things that we're going to be talking about. Okay, anyway, let's focus on the first thing, which is extraction of the hashes from ntds.dit. So we're going to do it this way. First of all, let's just get in here. We're going to technically, and we can do that, create a copy of ntds.dit. Yeah, so there are, as I already mentioned, plenty of ways of how we can perform that, but let's do that. And I would like to show you how we can do it in two ways. So first of all, in order to perform the copy, I will need to get into our Python and ESCDB export, because we're going to be exporting the content of the ntds.dit into different types of tables, as of course this is simply speaking a database. So we're going to do it like this: VSS admin, create shadow, and I'm going to do everything step by step, because if you are learning this part, then it's quite easy to perform this kind of activity. Yeah? So we are creating the shadow copy for the C drive or whatever you have ntds.dit. Of course, for the system hive, you will need to do that. Yeah. So it could be D or whatever you're going to put it. Yeah. So here we have, of course, a certain link, and that particular link we're going to copy from it. In this particular case, so it's like a root path. So we're going to do Windows. So in Windows, in this case, yeah, system 32, and then config, and then a system. Yep, okay. And then we're going to do the same story, but in Windows, we're going to do that for the ntds.dit. Here we go. Perfect, yeah. So I've got these two files needed. Now, this is lovely. Question is, what can I do next? Yeah, so how can I extract the whole content? And ESCDB export, so I would like to show you that everything from the beginning, so that you can perform this activity. That's the file, that's a tool that you are able to find on the GitHub. It's like as simple as this, the community tool. It's free, and you can use it for extracting the content of the ESCDB format. Yeah, so over here you got, of course, a bunch of options, but we're going to use just a default option for extracting of whatever is in ntds.dit. And I already have a folder like this. It takes a little bit of time. It depends, of course, on the domain, but let's see. So we're going to get into our Python, and we're going to do into ESCDB export, and here we go. Yeah, so this is basically the piece of particular extraction that we have over here. Yeah, so well, for the small database we can do that. Of course, if you want to do it for a couple of thousand users, it's going to take approximately 10 minutes maybe or something. Yes, for this domain, which is a lab domain, it's going to take a small moment. Yes, so we can do that. Now, exporting, of course, all the tables. In the meantime, let me explain something. So you are wondering maybe, like, how could it be that I do have here Python? Well, as simple as this again, in order to be able to extract the hashes from these tables, I'll need Python to run. And that Python, and that's a little bit of a hassle, you're going to find, of course, the 64-bit Python and 32-bit. So, well, yeah, we could be like, okay, let's just go for 64-bit. Well, yes and no. It depends really on what do you use it with. So it depends on the different types of Python scripts, etc. So if you're going to download 64-bit and everybody in the internet claims that that script is working and not for you, then maybe you should try 32-bit, and it's always good to have it this way because there's a bunch of other tools like volatility for memory analysis where, well, if you have 32-bit, 64-bit system, it doesn't really matter, but what matters is modules. So the way is how you're able to expand the possibility to analyze memory by, for example, using some kind of a custom module. So what's the lesson over here is that if you do install Python, make sure that you've got the 64-bit version and 32-bit version because it depends really on the tools that you are using it with. Okay, great. So what do we have over here? It's the extraction of all these different types of tables, and they do look like this. So as you can see, we've got data table, link table, etc. And this table, it's the biggest one, which means it's probably something that allows, well, it contains all the directory data. We can assume that, and we know that as well. And whenever we combine that with the link table, that's the moment we are able to decrypt, encrypted, of course, hashes. And hash, it's a function, yes, which is a one-directional function that it's not reversible. We all know that. But that value itself, it's encrypted within the ntds.dit, and that is something that we will need to grab. So how do we do that? So let's go next. So I've got this ntds.dit export thing, so we're going to just cut it, and let's go to in this particular Python again. And this time we're going to go to ntds.x, and I have over here different types of versions, different types of files, etc. So we can take this. I'm going to put the new one. And as well, we need to take another thing, which is system, and I can take it, and system will be needed to decrypt that content of these tables here. So I will need to put it somewhere out there. Yep, here we go. I already have a file like this, so I can replace it. I'm working with the different types of settings over here as well. Very useful setup, by the way, to have like on a virtual machine. You are able to process pretty much any system and any entities that you got. Okay, so here we go. What's next? Next is that we're going to extract the content of the hashes. Let me just clear the console, well, the content of the tables to get the hashes by using the script that is written by a very, well, good colleague of mine, which is Csaba Barta. This is DS hashes Python, and DS hashes Python allows you to combine what we've got within the ntds.dit export folder, and this is the moment we combine the data table and we combine the link table, and that's it. They might have a different numbers for you, so you just need to check. Sometimes I see that link table has 7, but in general, you just need to check it by yourself. So just be prepared to use these names, all right? So we've got that, and of course, we've got a parameter which is called password hashes system hive. We specify system because it's in the same directory, and after a little moment you will be able to extract all these hashes, and that is pretty lovely because this is how you are able to eventually perform the audit of if your passwords within the infrastructure are reused. Also, this is how you're able to perform the audit very, very quickly if, for example, by generating different types of hashes, people are using different types of simple passwords like company name and, for example, 123 or anything like this, company name 2018. So that is something that you are able to, well, grep over here. And what we got over here as a result, so these are, simply speaking, hashes. So let's take user, which is called test1 as for the example. And over here, we're able to see the LAN manager, and here we're able to see the LAN manager hash, and here we're able to see the NTLM or NT hash, as we can call it. And that is something that is used, by the way, within the PASI hash. So PASI hash can be happening as an attack on the domain level as well, and also on the local level, and that is something that we're going to be playing with today. So first lesson over here, how we're able to extract the hash for this particular situation from ntds.dit. Now, the question is there any other way of doing it? Answer is of course, because for real, what you need from the system hive, it's the boot key. And the boot key is really a key to success. So I would like to show you something on the other example. So we're going to get technically over here, how we're able to extract the boot key, and whenever we do have ntds.dit, how we're able, by using or having just the boot key, to extract hashes from the domain controller. So this is what we're going to be playing with. So let me just go over here, and then we're going to use for that purpose CQ secrets dumper, like this one, and then we're going to do that with the option boot key. You might be wondering, where does this tool come from? Well, that's one of the tools that we have in our CQ kit, and these are the tools, for example, that we are sharing on our blog. You can check out on secureacademy.com. This is our educational part, and as well the closest way how we're going to share the tools. I'm going to be in Geneva on the Insomnia Hack conference, also delivering keynote at Helsinki, so I'm also sharing those, and at Black Hat in Asia very shortly, so next week. So this is basically how we are sharing those. Yeah, you can also grab them, as I already mentioned, from our blog. They're all free. You don't need to do anything special here. We are always sharing knowledge in cybersecurity, because there isn't much out of it. Anyway, so well, we're gonna take this boot key. What else? So let's take this guy. Here we go. And the next part that we're going to do, and I do have that copy already here, I would like to extract these hashes from the dry copy of ntds.dit by maybe using some different types of a technique. So within the CQ tools, I've got a tool that is called ntds, lovely, and this is the CQ ntds decryptor, and it takes a couple of parameters. Yeah, they are quite important over here. So we've got well, we have to specify a boot key to be able to get access to encrypted data, but then we can also specify, we have to specify the ntds.dit. We can specify where the hash is going to be exported, and all the different things like PFX or KDS root, which is something that we're going to discuss later on. Yeah, so let's do it this way. Boot key, and we got that pasted, and we've got file ntds.dit. We can do that, and then we can get into out file. Perfect, and we're going to do hashes.txt, which we can open later, and PFX. We can specify over here export that PFX, and we can specify over here KDS root key and kds.bin, and that is something that is exported to the file, which is a part of the data protection API new generation in Active Directory. So that's what's happening. Yeah, as you see here, we are that's all right. We are here extracting different types of information from the domain. Things like KDS master root key that is used to decrypt different types of user secrets to be covered. But then if we get into hashes.txt, here we go, then you are able to see that that's one of the ways to extract it, yeah. And we are able to see that not only we're getting here the hashes of the passwords of the users, but also hashes of the machine account, machine or computer passwords, yeah. So this is one of the another ways of extracting those. Okay, so domain is done, yeah. So as you see, it's quite straightforward. If you're wondering like what the hash is, it's nothing but a Microsoft implementation of the MD4. You're able to calculate it clearly, and then you're gonna see that part. So the only thing you can do about that is to, simply speaking, crack it. Okay, guys. So we've got this part. Now let's move forward to the next part that is worth having a look, which is related with extracting different types of hashes on the client, yeah? And that's going to be quite straightforward. So how are we going to do that? And it doesn't really matter where we're going to do it. It's really in the same way of doing this. So we're also providing a small tool for that. And in order to be able to talk to some database itself, system no, but some yes, then you need to, at that certain point, be or have the possibility to become a local system, and that kind of escalation can happen if everything is of course up to date, or if we have like exploitation management, code execution prevention, etc. by well, simply speaking, elevating yourself legally, or of course by the vulnerability. Yeah? So this is another way of performing that. And that these vulnerabilities, they don't happen that often. They do though, but not that often. Okay, anyway, so we've got this. Let's go to tools on our side, and then what I will need to do is two things. First of all, show you if I do CQ hashdump version 2, which allows us for a couple of operations over here, I'm able to dump some. Yeah, so the only thing I'll need to use is the sum dump. This is, by the way, one of our tools. Yeah, so we can do sum dump like this. And then you can see that requested registry access is not allowed. Yeah, well, true that. Not a biggie. It means that we have to get and elevate ourselves into local system. So we're going to do ps-exec minus s minus I minus d cmd.exe, and this, by using the privilege to be able to, of course, impersonate, allows us to become pretty much immediately anti-authority and system. And that is pretty nice because it means that we are able to perform the same pretty much operation, but this time we should succeed. So we've got a CQ hash dump version 2, sum dump, enter, and then as you see, we are able to extract hashes from the local sum database. Yeah, so as simple as this. Now you could be also wondering, why am I using this tool, not like anything else that exists out there in the market? And I'll tell you answer for that, because that's quite simple. We don't want to run on the customer servers anything that we don't know. So that's why we're writing our own tools, and we've got over like 200 different hacking tools that we use. It's very useful because, well, code execution prevention could be an issue over here as well, but then it's great for the customer that some piece of code doesn't really run. And there are various ways of running it anyway, for example, through PowerShell, etc. Okay, so let's move forward. So we've got a CQ hashdump version 2, sum dump. Okay, so we've got this part. Now question is, how can we leverage this position as a hacker? Yeah, so this is basically something that we're going to start this called pass the hash attack. One of the most popular attacks ever, and as simple as this attack relies on the possibility to authenticate with the hash by, for example, using, at that moment, a wdigest provider. And that is quite funny, because we could be thinking, how could it be that we are actually able to authenticate by using the hash? Well, it really depends on the provider, yes? Like, for example, IIS, so the web server by Microsoft, which is a really nice solution from IIS 7 and for real IIS 8 when there were a couple of changes introduced, and it makes so much sense. Basically, you are able to use something that is called digest authentication, and that digest authentication is, simply speaking, leveraging a hash. So we could be like, okay, where's the difference really in between like using a clear text and using a password and using the hash? So no difference at all. So technically, what we can do is to use this, and assuming that wdigest provider works there, and that's just a default Windows configuration, we should be able to take it and move forward. So let me show you this, because it's going to be quite interesting over here. First of all, what is important for us is to see who we are. Yeah. And as you see, I'm here local Paula. So this is a Windows 8 client Paula. I'm not even logged on to the domain. Yeah. For the fact that I'm elevated over here, it means that I am the local administrator of that machine, and that is necessary, by the way, for you to start this attack. We could be thinking, oh, that's boring. Well, not really, because it's not a rocket science. In order to be able to work with the LSAS, you need to have a debug privilege, period. Yeah, so that is one of the situations. Now, for some of you, maybe it's no longer an issue. Yeah, so your users are not administrators. You are fully patched. You are managing of what kind of code executes out there, and that is a very good way to achieve the success. At some point, There's lots of situations as well to have a look at that are managed over here. One of those things is, for example, the fact that this attack only works because local administrator passwords are the same. And there is a simple solution for that with the basic management, but it's there. It's called labs, local admin password solution, and that allows you to randomize all these passwords. Anyway, so these are the preconditions really for the pass the hash attack to work. It's not that improbable, it's just that you need to have appropriate conditions, and unfortunately, lots of companies just meet. So let's see, I'm going to take this hash. So this is MD4, once again, our anti-hash, as we should call it. And over here, well, we are system, we no longer need to be the one, so I can technically, even though if I want to, move on to this direction, yes? And what I would like to show you, that over here, I've got the piece of code, and that is indeed Mimikatz, but that particular Mimikatz is our edition. As you see, Secure Edition, we do have a chance to cooperate with Benjamin, and we had a chance to work on some versions, etc., or cooperate on some versions. And eventually, our versions, they are not recognized by antivirus. And that is actually quite cool, because it means that if you don't have any code execution prevention solution out there, then there isn't much you can do about this. Okay, so let's move forward. So we're going to do that. Privilege debug. And if it says OK, it means that we have it. It means that basically we are right now able to work with, maybe, depends on the version, for example, creation of the remote threat into LSAS. And because threats, they do share memory with each other, and if we control that remote threat, then we are able to read of what is within the memory of LSAS. So we've got that concept, yeah? So we get a Mimikatz, and then we're going to do like this. Secure LSA, PtH, pass the hash, user, administrator, domain, localhost. We're going to do the lateral movement in between the local accounts, and we're going to do NTLM, and that's the moment you are actually specifying this particular hash. Hopefully it's in the clipboard. Here we go. So we've got secure LSA, PtH, administrator, localhost, etc. So we're going to elevate ourselves locally into administrator account. Okay, perfect. So what I want to show you right now is that if we do have that situation, let me just log on to the server once again. Here we go. With the pass the hash, how does it work? What do we use it for? Please have a look. If I do fire up psexec again and I try to authenticate to 10, 10, 10, 200 by leveraging cmd.exe, then it tells us the username or password is incorrect. Correct, because here we are using the single sign-on. So that's not a big deal. It's kind of clear. So there is no user like that. So I cannot just pass the credentials through LSAS seamlessly, but I need to, over here, either say the username or password is incorrect, but for example, in an Explorer case, maybe we should be, or we could be, asked for the username and password. So it depends really on software and how does it react. So here we've got secure LSA, PtH, user administrator, etc. And what we did right now, we have created a token where we have passed this particular hash, and now we're going to be acting as this particular user. Now, you might be wondering, okay, then, well, I could do that for pretty much any type of a user over here. Well, yes, but for the domain users, it's a little bit more difficult unless you get them. Unless you manage to have the memory dump or something, then you are able to perform with the domain users. Like here, for example, what is important is that, well, we know how it works, so that locally we created the token. By the way, what is important to mention is that you can also, by the way, create a token of any type of an account that you want to. You want blah blah account, you got it. Yes, you can do that. That is, by the way, one of the privileges of the token creation. That's why when you log on, it's so important to differentiate two things. First, log on itself. Second, handling of that. So for the fact that I'm logged on, that's okay, like we have verified it successfully. It doesn't mean that I have to have like a session afterwards. Yeah, that is basically how Explorer starts, etc. How we are able to see our context. So this is how Windows is designed, but it doesn't have to be this way. So it can be that when we authenticate, then nothing really happens. Yeah, and what I want to show you over here is that, well, we have created here a token of administrator. Now, geeky part, look at this. This will show something else. So we've got over here W8 client, Paula, etc., which is still myself, but that is because cmd.exe is not able to read this information from what we got. So the next step at that moment is to actually use Mimikatz. And we're going to use for that purpose PSExec, and then we're going to do 10, 10, 10, 200, because I would like to leverage over here on cmd.exe the same situation that we had before, but I've got it with a different token. So let's see if that works. And hostname, as you see, I'm on a web server right now. Yeah, so that is basically how we are able to operate on that part. Yeah. Now, again, as I already mentioned, antivirus is not really helping here because you are able to generate the code that nobody has seen, nobody has tested before, and even though we could be like, oh, but then we could recognize it by the behavior, well, not necessarily, because if you define your own behavior, then you are able to pretty much hide yourself, and that's what we are talking about. Okay, anyway, so we've got the pasty hash that is super duper ready. Okay, so what's next? What can we do next? Well, what is next is that I would love to show you how we're able to extract different types of information, different passwords, as we mentioned, from the different areas within the operating system. And then later on, we're going to get into extraction of the user secrets, and that is pretty cool. So let's dig in. First of all, small picture. And then, forgive me, I was never a good painter, like ever. Oh, not this one, no. It's just a website. Here we go. We can do here the MS Paint. Yeah, perfect. Okay, great. So we're going to use this guy. Now, how that's going to work? Well, I would like to paint you a little bit of things, a little bit of details regarding of what we're going to do. So that's going to be that data protection API. And that data protection API, let's paint it in this way. It's divided into a couple of things. First of all, it's divided into local system data protection API. That's the first thing. Local user data protection API, and the domain user data protection API. Yeah? So that is a little bit of a flow. Now, question is, okay, this is beautiful, but what's next? What's next? So local system itself, of course, it needs to be capable to decrypt all the different types of secrets that we have at the moment we restart our computer. So yes, it's very easy to guess that, well, when we can extract hashes online, offline, and so on, any type of a secret that is managed by the local system this way is also, by the way, decryptable offline. So that involves, at that point, the service account secrets, that involves all the other secrets, IIS, stored secrets, so anything where you've got a local system that is attaching to some kind of a configuration to load it for you. Yeah. So you just need to completely understand that, because if you ever wonder, like, oh, where I'm able to find this password, is this password saved somewhere and so on, of course there is a very nice way to figure it out. And that will be, for example, Procmon, to very quickly check for it. But you just need to know that if there is a local system writing it, it's like, you got this completely covered, and you are able to extract this information somehow. Okay, so of course lots of them is coming. Local user and the domain user, it's something a little different. Yeah, why? Because local user also has its secrets, but these secrets are accessible in a very short words by something that we call a master key, and that master key is encrypted with the user's password hash. But the thing with the local user is that it's using SHA-1. Now, SHA-1 of my passwords, we are not using SHA-1. We already know that we are actually using MD4. So why SHA-1? Well, very, very simple. Because if I do have access to, well, in this particular case, the SUM database that contains all the different types of hashes, if I'm able to extract it offline, which I am, we all know that, then what I'm getting from that place, it's the MD4. And if MD4, by the way, in here was engaged in protection of the user secrets, then everybody would be able to grab all these secrets, because MD4, where it's within the SUM database, is just one step more. So that's why SHA-1. Yeah, so offline attacks are not threatening your secrets. And that is important to know from the local user perspective. Now, what about the domain user? Oof, that's a different story. within the domain user, when we've got somewhere over here a secret, what is important for us is to know that there are two ways of getting access to those. It's not just SHA-1. No, no, no. This is, of course, master key, and that's, by the way, the same master key as well. So it's the same. I'm going to put S for same. So it's just one. Well, it's the master key, by the way, but it's in the same master key container. That's my point. It's just a file. And there are two copies of the same master key. And what is important to know is that that domain user, well, first of all, it can use its, this time, MD4 to protect that secret, because offline, or in general in the computer, the hashes of the domain users, they're simply speaking not stored. We could be like, oh, what about cache credentials? Yeah, there is no such a thing. Yeah, Microsoft doesn't even call it this way. Please remember this. Microsoft calls it cache logon data, and within the group policy, this is how you can set it up. And I'm going to be talking about it so that we understand clearly of what this is all about. Okay, so MD4 of the domain user, and something that is quite funny, because here we are referring to something that is stored within the DC, yeah? Something stored within the DC. So, well, we could be already thinking that whoever owns DC, then this person will be able to decrypt user secrets, and that is a very, very correct conclusion. So let's see what we got, yeah? And data protection API system, and then, of course, data protection API user. All right, so let's see. I'm going to switch to another machine, which will, of course, we're going to be using it for the further analysis. Okay, here we go. So what do we have here? Well, we do have over here, well, IIS. Let's start with this guy. And IIS, it's beautifully leveraging data protection API of Windows. Like, by the way, gazillions of applications. And I'm not saying it's bad. It's actually pretty good, as long as you know how to use it, yeah? As with everything. So we've got over here Internet Information Services. We can get into, let's start with the most difficult, which is the centralized certificate. And if we do get into edit settings, then you're able to see that we've got certificate, private key, password. So you're like, yeah, but like it's just like 8 characters. Yeah, so we could, let's just count it. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so that looks like kind of a password, especially if they will be having a different length in characters. That will be something to spot. But yes, if you are wondering where this password is stored and how is it stored, answer is by leveraging data protection API, and it's in a registry, like a very unusual situation and place for the IIS to store the password like this. So how we are able to find it? Well, this is what I was mentioning at the very beginning, that in order to be able to perform that operation, it's, well, absolutely advised to run something that we call Procmon. Here we go. And Procmon, or Protsmon, as we call it in Europe sometimes, has the possibility to configure different types of filters. And what I have over here, it's a filter that says category is right. So you can add it this way, by the way. So you go over here, like you choose a bunch of categories, yeah, and you can say the category is, and then you can choose from the drop-down list of what that will be. For example, like here you've got architecture is X, yeah? Fine. So let's say we don't want that, but this is exactly what I did for that file. So category is right. Okay, so I just pressed right, okay. Here we go. So I can have, or I do over here, and I see filtering, because normally it's like we have already like 60,000 events, and on this output we only have a couple. Like I know that there is something that will not be related with my attack, so you can make some decisions, and all is for one thing, to check where the password is stored within the IIS. So yeah, so that's not much, and I know that I don't need this and so on, so you could be like technically removing all those things. By the way, things to the event log are written, things to the firewalls are written, to the txt log files, etc. So it's plenty. Let me just take this out because it's messing around. Now we've got SVC host and we've got Explorer, so that's not much. Of course, SVC host can be also dangerous here, but that's not my point. Anyway, so let's do one thing. We're going to change here password by adding 1 at the end. This guy doesn't really tell you that this password is wrong. It's just that it says kind of indirectly that I cannot connect. Fine. So what we're going to do next, we're going to technically analyze of where eventually this password is stored, yeah? And we're going to be learning how to decrypt it. Here we go. Let's see. Oh, here we go. This is this momentum. Beautiful, beautiful. I'm going to take the little bit more filtering. Network goes out. These files go out. Let's just keep the registry. And this one goes out. SVC host, as we can see, goes out. Yep, perfect. And SQL Server, goodbye. Yep, okay, perfect. So what we can see over here is that this is one of these weird situations where IIS actually stores this type of information within the registry, not within the configuration file. Let's see what we can do. So we've got here something that's called private key password. So I would do just jump to, and we've got this. Fantastic. And it looks like, by the way, base 64. Smells like base 64, but it's not base 64. It's just the way how we are storing things within the registry. So in order to be able to show you how we are able to decode it, it is important a little bit for us to like technically reset all these filters and search of what is around this values over here within the private key password. And that's perfect. Have a look. INET Manager uses over here some IIS providers. Yeah, so this is basically the setup. And it goes to local machines, software, Microsoft, cryptography, default, provider, Microsoft Enhanced RSA and AS cryptographic provider. Fine. So we could be like, oh yeah, okay, so it's using built-in Windows mechanism. Not a surprise, but at least you know which keys are used over here, and there's also like preferred key. And the time for us is to learn how to decrypt this part, yeah? Well, one thing for sure, and that's the knowledge part. We need to know that within the IIS, for example, the keys are, well, stored as a system keys, and that's why it's like this is because service runs a system. But how we are able to extract them? Is there any tool we could use? Is it really that if I copy this file and paste it somewhere else, then it will be visible? Answer is no, absolutely not. That's the data protection API system. Don't forget the boot key part. So it's different on the other server. So how can we extract that normally so that it could be imported somewhere else? ASP.NET_rec IIS. And then we're going to do, sorry, not this path, of course. Windows, Microsoft.NET, Framework 64, and version of framework. Yep, not this one. Let's just choose 4. Oh, here we go. So now ASP.NET _rec IIS. And if we do it this way, then of course there is this option -px, and it says export an RSA keeper to the file. Okay, awesome. Let's do it. So we're going to do it like this. ASP.NET rec IIS -px, and then it says container. Container is called IIS Windows Activation Service Key. You could be wondering, how do we know that? You just learn this. That's it. So these are the names of the IIS containers for that different crypto material. And we've got a file, and file is really the place where we are saving it. So it's going to be ctest.xml maybe, and then we do -pri option to export the private keys. Perfect. So we're almost done. The next thing we need to do is to run the script so that when we've got these keys, when we've got the encrypted blob, question is, would we be able to move forward with it? So this is what we got over here. So first of all, we will need to read, here we go, this the content of the test.xml, and that is something that we got on the C drive. So let's do that part. Now, if you wonder how it looks like, you can export the keys in the same way, but if we do test, it looks like a regular crypto key, by the way, as you see. Yeah, so that's basically the key that we are using within the IIS. And you can import that, by the way, on the other server. So all the content that you had encrypted within your hundreds of websites, you are able to also access from the other server as long as you import that key. Okay, so we've got this. So we could see the encrypted data. We are defining the RSA variable with the RSA crypto service provider. And then, of course, we're using this particular key within the crypto service provider. So we've got this part. Now, we're going to read stuff from the registry. This is pretty much the place that we've been to. So it's a local machine, software, Microsoft, IIS, central provider, etc. So we've got this part. Let's do it. And then I just want to show you one thing, because if you're curious, then basically how when we decode that what we had in base 64 in registry, so how does it look like? And it's technically, and let's just use well, first of all, you can have the binary, but the second we can display the variable over here converted to technically regular text, and as you see, it's just like a big mess. Yes, because that's the blob that has been encrypted by IIS over here. Okay, anyway, so we've got this part. Now what we're gonna do? We've got our path variable, and our path variable, for your reference, let's just do that $path. It's just a byte array. Yeah, so not a big thing, but we're going to take character by character, and then we're going to decrypt it. Now, the key to success is to reverse this array. So let's do that. And then we are almost able to decrypt the content. You might be wondering why we're reversing this array, and that is because very often in Microsoft Windows, there is no like a super standard in what do you actually use, like little endian or a big endian. So it really depends. You have to check. That's the easiest way to figure it out. And in this case, we had to just reverse that part. And as you see here, we are able to extract the password from the centralized certificate support. But that's of course not everything what we can do. Yeah. So we could do a similar thing by, if we are here within the server configuration, yep, then of course one thing is connection strings that we are able to encrypt or decrypt, but it's also a configuration of the application pool. Yeah, so here we've got an application pool, it's called app1. Question is, it's running on Freddy Krueger, where this information is stored. And this information is stored in the application host config file within the C Windows System32 ntds.dit, and then you get there to config folder, and then you can see the file, and that you will see, by the way, that this particular value, so the user's passwords, it's encrypted. Yes, and the question is how and who knows it? And answer is very straightforward. It is encrypted by, again, system, data protection API system. So anybody being capable to talk to the service, to be a system, is able to decrypt all of these kind of secrets. Let's just don't waste our time over here, and let's just dig in into that part. So we're going to do Windows System32 inet srv. So this is pretty much the place where we've got all the content, and we can run appcmd as one of the tools that are allowing us to manage IIS. Well, PowerShell is much better than this, but this one can be actually used for the quick operations, and we are able to here specify that we should have appcmd list app pool, application pool, and then this is app1 because that's the name of the application pool, and if I just do that, then it just shows me basic settings. But if I do export for the text and then asterisk ping, then you are able to see that we are actually able to see the password in a clear text. So by knowing how things work, then it's so much easier to learn, of course, all these little details over here. Connection strings, of course, is the same story. We're able to encrypt them, decrypt them with the same story, is the same tool that we have used over here, which is ASP.NET _ rec IIS. Okay, so what else about the system secret? Yeah, well, quite a simple thing, but we couldn't deliver this session without really telling you this, and that is services. And whenever we've got service accounts, there are, and this is absolutely clear, some different types of services where there is no support, for example, for the group managed service account and so on. You always need to check, and probably there is, but sometimes, and I've seen an environment of a big factory which produces medicines where literally, believe it or not, it was actually quite horrible. There was like a Japanese provider of some equipment, etc., and they required their service to be running on a domain admin account. Of course, we could be like, oh my god, we've heard so many stories like this. Well, yes, but they are very real and they're still there, and that's the saddest part. So here, what I want to dig into is how we are able to extract that. As you see over here, I've got like a very important service, and I get here Freddy Krueger. So I could just type any password over here. But again, what I would like to show you is that we're going to do, well, first of all, Control X, and we're going to do a little bit of a filter so that we know what's happening underneath. So we're going to do category is right again. Perfect. Apply. Yeah, and we can start filtering. And what I will need to grab over here, it's the information pretty much stored within the registry, and I know that it's not really Explorer doing this, so we can skip this, and I know it's not a SQL Server doing this, so we can skip that, so that it's much clearer. Okay, fine. So apply. Yes, until I stop and start the service, it will not be effective. It is actually effective, well, not that effective in working, but effective within the registry. And so here, what you are able to see, as simple as this, it's a limited filtered output from the registry. And you can see that we've got this services.exe getting into the service configuration, but then we've got LSAS, so local security authority subsystem. So that is pretty much something that allows us to well, spot that that particular password is stored within the registry. And the question is how? And the idea, as I already mentioned, is pretty much the same. We're able to get the boot key, and then of course we're able to get access to that encrypted piece of information. By the way, in that place in the registry, which we have to run as a local system, and let's get there because we will need to eventually do that. I'm going to get into tools, psexec -si dcmd.exe. That is, for those who don't know, to -s run it as a local system. Here we go, and -i to make it interactive, because services running as a local system, they don't interact with desktop, and then -d to that stands for do not wait, but effectively it means to run it in a separate window. Yeah, so we've got that part. So that is, we're quite clear over here. Perfect. And what we're going to do? Well, next we're going to get into that registry area. So let's see where this part is in. Yeah. So just for the reference, why we cannot really run the tool as a regular administrator, because the security, click, it doesn't open. Yeah. So if we do run registry as a local system, click. Yep, yeah, and here security opens. Yeah, so we will need to get into place where we've got security, cache. By the way, that's the cache logon data over here. We can get to policy, and then we can get to secrets. Here we go. And then we've got, of course, all the various secrets out there, including this service. And there is, of course, a current value. And if I try to open it, then, of course, it's encrypted. Yeah, so not a big deal. There is also, by the way, in the same place, show you something that we call machine ACC, and machine ACC, it's nothing but the computer account password, which you can, by the way, also extract with our tool. Not that interesting though. Okay, anyway, let's have a look of what we can do here. So we're going to get into at that part. It's going to be users, this guy, desktop, tools, and then we've got a tool which is called CQ Secrets Dumper. So the same one that I use for the boot key. But at that moment, we're going to technically specify service, TENASRV, enter, and of course that shows us the password. So that is super easy, and of course every service that is running on the account that is like this, so just a regular account, it stores password in the registry, and you just need to check for those, and for the fact that password never expire. It doesn't help that much because these passwords are usually quite simple, etc. Sometimes we forget the password, so that's something, guys, that you need to know about. Okay, so a little bit of that. Now, the very last thing from my side, it is actually quite cool, because I would love to show you how we are able to leverage data protection API within the operating system. So I'm going to log on over here as the regular user. The password is p@ssw0 really, so I logged on to this machine. Let's see, hopefully it works, hopefully it sees the domain, etc. And what I will do, I will display over here, yes, perfect. Yep, perfect. I will display over here, well, something that we call a Chrome Pass as a tool, but for real, every single time you store the password in any type of application, by the way, it's crazy important to remember that all the other applications have access to it. So, well, if you are looking for some advice how to manage this, definitely storing passwords within the apps is not a good idea. Most of them, they use data protection API, which isn't bad. It's just that you need to be aware that all the other apps can use the other content of the other apps. So that's the data protection API user, and we call it data protection API classic. So question is, under what conditions I'm able to get access to this? As you remember, yeah, SHA-1 was for the local user and MD4 was for the domain user. So if I change the password in an illegal way, kind of like forcefully upgraded and so on, I shouldn't be able to see the password of the other user. And answer is, let's check. So we're going to do it this way. I'm going to reboot. I'm doing this to keep my picture clear because I would like to show you how we're going to be logging on with the cache logon data, so without really domain controller available. Yeah, so that's going to be the part over here. Let's just wait for the restart. So I'm going to restart that from the CD, DVD, or whatever that is in the current time. So we're going to get into network adapter and then not connected. So that's the moment we are actually, are we going to be logging on with the cache logon data, right? So let's just move forward. We're going to do next, repair your computer, and troubleshoot, and advanced options, command prompt, and we get this. So we've got a console over here, and just for the reference, just to make sure everybody can see, I'm going to change it to font to a little bit bigger. Okay, let's go to the D drive. And let's start the whole operation where we're going to be overriding cache logon data. And that's really cool, because next time we're going to log on, we're going to log on with a different password, because why not changing this in the registry as long as we know the algorithm? That's the first thing. And our team, by the way, fully reverse engineered that. And regarding the data protection API, we are the only team, as far as I know, in the world that from 2010, which was the last recalled research about data protection API, we have completely finished data protection API and data protection API NG discovery, so it's like fully reverse engineered. So always happy to explain to you how encryption of various passwords, etc. works in Windows. Anyway, let's have a look. So we've got the CQ tools, and we're going to get into Kiwi Secure Edition, and that is by the way our custom version of Mimikatz with the module that allows us to override cache logon data. So we're going to do it like this: LSA dump cache. Now you might be also wondering at that point, is it possible to decrypt cache logon data? Answer is nope, because the function is actually quite complex. It's called PBKDF2, and that function leverages a value, so it's like MD4 on the top of another MD4 of the user's password that is joined with the username, and we run it. We've got 10,240 iterations. We use HMAC for that, SHA-1, and for that we also use 16 blocks. So it's a pretty strong function out there that the only thing you could crack it is by leveraging rainbow tables, but generating them, it's going to be just super crazy. So we say crazy today, maybe not crazy tomorrow in cryptography, but for now it's a really, really big hassle. Okay, so we've got LSA dump cache. Let's overwrite instead of cracking this cache logon data. That would be the easiest way to get there. And then we're going to specify over here D, Windows, System 32. Oh, not 21. That year is already over. Okay, so we've got config. And we're going to do System, and then D, Windows, System 32, config, security, because this is the place where the cache logon data is, /kiwi, to override cache logon data. Awesome, awesome. So this part is done. So for all of the users that had cache logon data, we've done that. And after the reboot, question to us will be, okay, so knowing that all these user secrets, they do rely on basically, well, users password hash, and that is something changed right now, we shouldn't be able to get access to those. Yeah, so let's see, and let me show you if that's going to be indeed a way of getting access. Yeah, so let me log on as Freddy. This time, let me just show you how logon will not work. That's the also quite interesting part. So we get p@sw0d, and that doesn't work. So I'm going to put Mimikatz as a password, like this. Hello, and we should be able to get access to that part. Well, let's see, let's be patient. And the question is really, like, if we do have stored passwords within the different apps, are we able to get access to those? So we've got our Chrome pass, click, and then as you see, a little bit of time, we are trying to decrypt all the different types of master keys out there with our current password hash, and eventually that well, that doesn't work, yes, as you see. So, of course, we could be thinking that, yeah, but there is the second way I was mentioning for the domain users. Yes, that is something that is called a backup key. That is something that we have discovered. And if you are in a position of this, and we've got a toolkit for that, you are able to decrypt all the different types of user secrets. That is, though, a subject, of course, for our next part within the demonstration, and hopefully everything is going to be clear on the next, of course, webinar. I would like to show you how you are able to compromise secrets of all the users within the domain by having, of course, appropriate key that decrypts all the user secrets. So stay tuned. Just for the reference regarding the function, this is what I wanted to show you. Cache log on data, they are protected this way. So there's an MSDCC2 value, that's how we call it, and the function ppkdf2 I was mentioning, of course, has these arguments out there. Okay, so long story short, we did that, and we're running to the end. Yes, so but remember that pretty much lots of different passwords out there, they're all stored within a disk. Yeah, of course they can be extracted from the memory, like for example Mimikatz, and we're able to get the content of the live memory. We can also do the same, by the way, by running hyperfill.sys, grabbing that and extracting information from that place. So there are plenty of ways where we are able to take the clear text password, not necessarily of the currently logged on user, but also for the different types of applications, yes? So something to remember. Also, sharing is caring, meaning if you're going to share some kind of a memory dump, disk, etc., you're like, oh, I'm not storing anything anywhere. Of course, please do remember that you might be, that's the first thing. Some of the data protection API might be system-oriented so that everybody having offline access will be able to extract that. And as well, from the user perspective, if you have your user secrets, then most probably someone who will have access to the disk will not be able to extract those. I'm saying most probably because it depends on the application, yes, on the implementation. If it uses data protection API classic or eventually NG, then answer is no. But with this little asterisk out there, little exception, where you are able to extract some cool information from Active Directory, and that is for one of our next webinars. So we've got this part. So guys, hopefully you liked the presentation. Of course, I'm encouraging you to take our quiz. It's 25 questions, no registration whatsoever. It's a pure learning fun tool. So if you will have nothing to do, definitely check this out. We want to know how well you are performing in cybersecurity. We've got this little mission of educating in cybersecurity as well. The average amount is 13 out of 25 questions. We are disappointed, but I believe after this webinar, you're going to put the score higher. So take a challenge. And now it's time for Beyond Trust on the stage and Martin. And since Sarah mentioned that I should do a little bit of an opera, so Martin.
Hello, here I am. Okay, all right, so hopefully you can see my screen, and really appreciate that, Paula. That's fantastic as always. So, I mean, the biggest thing really, I mean, obviously we're here to talk about, password management is, really sort of providing some sort of separation from users, between when they're trying to access systems and, allowing them to be able to, if you like, sort of leave artifacts behind that, could potentially be compromised. So what sort of password safe does when we actually sort of look at the sort of overall capabilities is obviously password management, as you'd expect. But the thing is there's a lot of other sides around that, and so session management really sort of plays into this heavily because I mean, one thing I always say, and people get bored of me saying this, is the best password management system is one where you never have to release the credentials. So on the one hand, you've got to make sure that everything is rotated. So, that you never have anything that's stale, that you've got all of your passwords and the complexity is within policy, and appropriate for the platforms you're using. And so to that end, obviously, we cover just about every database, operating system, hypervisor, application, that's out there. We also tackle Windows services, schedule tasks, anything that uses those credentials, so that then when you rotate them, we'll go in, at the back end, and we'll make sure all those logon properties are, appropriately changed, and then, it indeed actually restart those services if required. A2A is a really critical aspect. I mean, here's the thing, people, when they have audits, and they're told that, you know, they have to be able to lock down their infrastructure and they have to provide rotation, very often, you know, they don't automatically think about, you know, all of the applications that they may have out there, you know, in the environment. And it's amazing, you know, just how many organizations, regardless of size, have applications that are using embedded credentials. Now, each of those embedded credentials, you know, are potentially things that become compromised. If the system that application is running on becomes compromised, you're giving someone another vector, you know, in order to be able to move laterally within the organization. So, you know, you really are, you know, as strong as your weakest link. To that end, SSH keys, you know, is another area. You know, I mean, you have, you know, very often, you know, Unix, Linux admins will use them because they're easy. I mean, you know, you set up, you know, public-private key pair. I mean, you put your public key out in all of your authorized keys files of the accounts you want to be able to access. You embed your private key or call it from a script. Now you can, you know, basically make script changes on bulk. But the trouble is, again, it's something that can potentially be compromised. So it's all around having a comprehensive solution to manage that, but then allow you to be able to log on without ever revealing them, if I can get my teeth in. So the other thing that we also do, you know, is, as well as logging people in, is we also record everything that happens. So full video recording of everything that happens in the interface, all the keystrokes, everything that's clicked on in the interface, even the stuff that gets put into the paste buffer. You know, if you paste something into an RDP session, we will capture it, we'll index it, and make that available. We can do real-time alerting. You know, we can even allow you to be able to be alerted on what users are doing in their active sessions. You can monitor, look over their shoulder, see what people are doing. If there's something nefarious is happening, or you can see people going down an incorrect path, you can lock their sessions, you know, or even actually terminate them if required. So as I say, you know, a very comprehensive tool set. So when we look at the way that the proxy works, it's what we call credential injection. So, you know, there's no clients involved. You know, the user would typically log on to password safe and say, you know, I need access to this protected resource. Could be an enclave, could be a PCI environment. I mean, somewhere that's squirreled away in your organization that you want to have some sort of separation from. So what happens is password safe then generates a unique one-time session key sent down to the host. You know, it then automatically invokes your RDP client of choice, your SSH client of choice. Like I say, we don't provide any stipulation in terms of the type of clients you use. So PuTTY, Mobile Xterm, you know, Flexion, TerraTerm, MSTSC, you know, on a Mac, you know, you can use Terminal, you can use Microsoft Remote Desktop, you know, Manager, a whole, you know, set of different things. So it's all protocol related. So basically, when it connects in, what happens is we then, you know, because we know which system, you know, that session key belongs to, we open up a connection on the inside and we actually inject the credentials into that data stream. Now, what that means is essentially the user is never exposed to the password, but they're never exposed to the username or even the host name. Now, all right, okay, you know, arguably the user selected a username, you know, from a menu, so they know what the username, they know what the host name is. But the important thing is that if somebody compromises the system that they're working from, you know, from their laptop, the desktop, whatever, there's no artifacts lying around. There's nothing that you can poke around in the memory space and leverage, because all you've got is a one-time session key that is used. You know, I mean, you know, and even then it actually has a short life. So even if you download it, you don't use it, it times out, you know, in about a minute. So when we then start looking at the type of recording that we do, this is an example of a you know, playback interface. It's very clean, it's very easy to use, very comprehensive. Doesn't matter whether you are recording applications that are being launched, you know, whether it's you know, an SSH session, whether it's an RDP session, the view's the same, the capability is the same. We record all of those keystrokes, you know, everything that they type. Obviously for, you know, command line environments, you know, standard out, you know, is captured as well and searchable. But as I said, everything you can, you know, that a user clicks on the interface. So as you can see for the screenshot, they click around, we capture it. If they paste something, you know, from their system into that RDP session, we'll capture it, you know, and we'll index it and we'll make it searchable. The ability for auditors to be able to go in and say, yep, okay, I'm going to sign off on it, and actually give you an audit charge. So as I say, very, very comprehensive, you know, recording facility there. Now, it's one thing to be able to say, well, here's some tools that you can use, but you also have to be able to provide some gating factor. You've got to have some access control mechanism. So what we do is we go a little step beyond, if you like, sort of traditionally what most vendors provide, which is, okay, allow Bob to access, this group of systems, or log on from, 9 to 5, Monday to Friday. So what we do is we actually provide contextual security. So it means that when a user logs on, we evaluate, obviously, who they are, where they are. We look at the IP address that they're coming from, the day, the date, it's a calendar built in there, obviously the time. And what we do is we provide certain access policies. So, for example, if I log in during the middle of the night, I'm coming from a VPN concentrator, I'm going to have an access policy that only gives me access to a certain group of accounts, maybe the firewall accounts on a certain group of systems. Maybe that access policy, because there's no one around, is going to be auto-approved. But, maybe that there's going to be some additional login that's required for that, or an email notification that goes off to the help desk to notify someone that I'm actually performing this action. Whereas if I log in during the day, maybe that doesn't happen. So again, it's all around providing contextual gating depending upon what you're trying to do. Now, I try not to make this too slidey, so I'm actually just going to kind of leave you with this before I actually go on to the demo. It's really not just us. I mean, of course, I'm going to crow about it. I'm the product manager. I love it. It's my baby. But at the same time, we have analysts, that actually say it is a great product. I mean, they actually put us, really at the top. And certainly the Forrester one on the left is very appropriate. It's a 3-month exercise. It's not just analysts saying, okay, well, this is your marketing stuff, and we're going to put you in a table, check the boxes, and then grade you on that. Every single vendor has to go through a strict evaluation. These are the things you have to do. They walk you through every single step that you have to document. They have to walk through it in a lab. So this is really people that are actively using all the products in the market and then grading them accordingly. So anyway, so I want to leave you with that thought, and let's actually switch over to the demo. So big thing, I mean, obviously, user interfaces are great, and, it's nice to say, yeah, okay, we've got a pre-interface, that users can go in and, they can go in and, access the system. So perfect. Now, one of the big issues that I've seen in this space over the years is when you're trying to implement privilege management is you're always going to get some reticence on behalf of the admins because they're used to doing things in certain ways. They used to be able to, using certain tools, they go in, whether it's, a password that's known to, they committed to memory, they've saved in the tool that they use, or, heaven forbid, written on a post-it note somewhere, they're used to doing things. And so, as you start to drive admins towards tools to say, well, now you've got to go to this web interface, very often you're going to get pushback. So what I'm going to do is I'm actually going to show you, if you like, a traditional way that a lot of products do. Which is to be able to say, okay, here's an account and I want to be able to open up a session onto this. Great, okay, so I'm doing this all through a web interface and, that this is logging me on. Now, the way that, we find a lot of customers wanting to use the product is they want to use, something we call direct connect. So essentially, I call it like privilege without the pain. So it's bringing sort of PAM to an interface, near you. That's kind of all my marketing slogans out of the way. But essentially what that means is, rather than actually go to any of these web interfaces, I could just open PuTTY here. I've got a shortcut that I put in. So, basically I want to open up, the admin 01 account on my policy server. So basically I open up the shortcut. Let's just drag it over here. And I'm going to put in my Active Directory credentials. Okay, so as a user. Now what this is doing is this is actually opening up a connection directly through the proxy. So I haven't actually had to hit any web interface. I'm still using PuTTY. If we took a look, from the admin session, and, say I was an admin and I wanted to look at all the active sessions, you see that here's the Windows session, that we got in progress. Here's the that Linux session. So, everything that I'm doing, within that PuTTY session, it's going to be captured. So, hi there, goes in. So, I can view that, and also as well, that's being captured in the index. Now let's say, for example, they're doing something nefarious. Now typically with a lot of products, they have a terminate option. Now with SSH, it's kind of a bit of a no-no because it's pretty fatal. I mean, that way, you could be killing off jobs. You might have corrupt file systems. All sorts of stuff could happen. So typically, you find people don't usually use those on tools. So we got something called lock. So if I lock it, what that means, if we take a look at this session, it says your session's been locked. Please contact your administrator. The SSH session's still open. It's still there. It's still running. But what I've done is I've stopped the user's ability to be able to interact with that session. Now, if everything's okay, well, I can just unlock it, and the user can go about their business. So see, I can carry on doing what I'm doing. Now, it's exactly the same thing with RDP. So if we take the the RDP session that we've actually got running here, and let's say I actually sort of park this over here for illustration. Again, same sort of thing. I can view exactly what's going on. So anything that's happening on the screen, I'm able to actually view, what's happening real time. Again, everything that I'm clicking on, clicked on, Internet Explorer, Open File Explorer. Now, if something bad's happening, lock. Now, you can customize this. So, you could actually have something that, it essentially, has your company logo, has a call to action, say, contact the help desk on blah, 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 suspicious activity detected. So the key thing is, this allows you to be able to, say, like, if you see something, do something. You don't have to worry about, okay, is this something that's going to be catastrophic that I'm going to be told off about later? I can just go ahead and lock it, and if it's, seems to be okay, I can unlock it, and the user can carry on doing exactly what they do. Now, as you'd expect, I mean, within a tool like this, we also allow you not only just to be able to view the live recordings, but we can also actually allow you to be able to replay recordings as well. And, the important thing, here is when we're looking at replays is that people tend to think of, locking down what the admin's doing, and auditing what the admin's doing. But what about the reviewer? All of these products actually have the ability to be able to review sessions. So, what if, for example, I was able to go in here as a reviewer and be able to look at information, and I start playing it back, and, I actually see personally identifiable information. Now, that could be patient information. It could be, intellectual property belonging to the company. And so what you have to do is you have to think about these things and start protecting yourself, not only against the administrator, but also against the person that's actually doing the auditing. So for that reason, what we do is every time somebody looks at this recording, there's an audit trail. So, it also allows, an auditor to be able to add comments in as well within this. But the key thing is actually providing some sort of capability to make sure that, anybody that has access to a recording, has some sort of audit around it. So as I say, that's really, the basic functionality that I want to show. Password management to an extent is password management. I can show you a password being released, but I'm sure you're all going to be yawning and going to sleep. So what I want to do now is pass it back over to Sarah, and we'll do the poll Q&A and then move on to some questions.
Awesome, cool. Okay, so let's go ahead and launch this last poll. Thanks so much, Martin. At this point, would you like to schedule a personalized one-on-one demo with a Beyond Trust security engineer? You guys should see that pop up on your screen right now, and if you are interested in being contacted for a more thorough one-on-one demo or a conversation about PowerBroker Password Safe or any of our other PAM solutions, please select yes, and then somebody will reach out to you directly to schedule that time to chat. And then you can get all of your specific questions answered with one of our security engineers. So I'm going to leave this up, and let's dive into some questions. Let's see. This came in for you, Paula. I don't know what they're referring to, but maybe if I read the whole question, you'll understand. So this is an example. If you already have access to the domain controller, would the process be similar if you gained local access to a machine in order to gain lateral movement on the network?
I wonder, like, where this is referring to, but Well, if does this refer to, for example, ntds.dit extraction, well then yes, you will need to be that on the domain controller. You could, by the way, pull out the data if you do have a possibility to replicate all. That's something that in some configurations, in some environments, SharePoint accounts have, and that is the privilege that is by mistake given, because there was a book before by Microsoft, and there has been a mistake, so lots of people actually configure it this way. If this is what we are referring to, we could be referring as well to PtH, but we started that from the workstation. And regarding the data protection API, well, it depends really where we are starting with. Well, all the different types of blobs, as I mentioned, they can be decrypted by either the user's password hash, whether if it's SHA-1 or MD4 over here, or eventually this key that is within the domain controller. So that, yes, could be, by the way, part of the lateral movement while we are replicating the content of the ntds.dit. Could be, and SharePoint accounts for the user profile replication. That's pretty much the place to look at.
Another one for you, Paula. Why do we have 3 different kinds master root keys?
Okay, I see what you are referring to. You are referring to the output of the tool that I showed at the very, very beginning, where this was the secure ntds decryptor, and we had like a master root key, and so on. There were 3. By the way, it doesn't have to be 3. It can be like 1 or 2, etc. They are created upon the usage of different things. First of all, it could be this first command that you need to run before you generate any like a GMSA. So that if you search for the KD as root key within the PowerShell commands, that's, for example, what you generate, because from that key, different things are pre-calculated. So the purpose could be completely different. So GMSAs and password generation, here is one. Second, it's actually the one that is taking part within the data protection API NG for the TFX SID protected files, and that is a functionality that is introduced in Windows Server 2012 R2, so Windows 8.1. So then for that purpose, you've got another one. And that's why whenever you use ASP.NET Core, same story, you've got another one. So these keys aren't that, there aren't that many of those, because you don't use these functionalities that rely on those often, but when you use them, they're quite critical. So there are 3 because I use 3 different types of functionalities that are requested for those keys.
Okay, let me go ahead and close this poll. Thanks, everybody. And jumping into another question for Paula, just curious, NTLM hash can be passed only one time. Is that correct?
No. You can pass it like, I mean, the question is like, what does it mean one time? Like one time and that's it? No. You can pass it to pretty much, if you have that for the local administrator, let's say, and you want to do the lateral movement, and there's like 1,000 other servers that have the same local administrator password, then you can pass it 1,000 times, if I do understand the question correctly, but there is no limit for that.
Paula, what types of malware would be used to provide access to servers and applications aside from getting access to the system hive and boot key?
Oh, okay. Well, what kind of other type of malware? That's interesting. Question is, of course, what you can get. Yes, and it could be a malware that it could be a part of some kind of application. For example, like we had in September last year, a very nice example of the CCleaner, which was, by the way, digitally signed, and everybody was like downloading it and installing it, etc. So any type of an app, of course, if we are discussing things like system, boot key, and secrets, hive, and so on, so you have to be a member of the local administrators, or at least impersonate, or at least have the vulnerability. So that needs to be kind of an app that can make some changes within the operating system. So it could be an application that you download from the internet, which could have a case like that. I'm not even mentioning things from torrents, because let's say this is passé, but I'm mentioning here the trusted apps where the security operations aren't really managed well, and then that software is getting published with the malware inside, but with the signature of the provider.
Okay, we'll give Paula a break, and I've got a question here for Martin. Martin, when you lock an SSH session, does that only lock user input, or does it stop processing?
No, only logs user input, so that any processing carries on. It's just stopping the user from interacting with that session.
Martin, where are you seeing the biggest risk for password management, and how do you address them?
I mean, the biggest risk at the moment, really, I think, is just the fact that people really don't go far enough. I mean, that they feel they've done their due diligence. That they feel that, yep, okay, I need to sort out my desktop, so I got my desktop sorted out, I got my server sorted out, but then they forget other areas. And as we see time and time again with attacks, people move laterally between systems. They find any vulnerability, even on an adjacent system or a vendor system, and they'll move throughout your organization. So I think complacency I see as the biggest risk.
Okay, one more question for Paula. Is MD5 used somewhere in hash generation? You've mentioned MD4.
Yes, it is, though by mistake sometimes you can hear that in Windows we do store MD5s, and that's absolutely not true. We store MD4s, but MD5 indeed is underneath used for the key generation, so that we are able to encrypt the value within the SAM database, where originally we store MD4. So we do store only MD4s, and MD5 it's somewhere out there used as a part of the one of the by the way algorithms within the whole process to encrypt the content of the SAM database, for example.
Alrighty, you guys, it is time to wrap it up. Whew, 90 minutes. It does go fast. So thanks everybody for attending and being here for the entire time. We really appreciate it. A reminder that you will be receiving an email with a link to the recording and the slides shown here today within 1 to 2 business days from now, and it will come from our email alias communications@beyondtrust.com, so be on the lookout for that follow-up. You can also download the slides via the handout section right now. A big thanks to our experts, Paula and Martin, today. Thank you guys so much, and to everybody who attended live. We really appreciate you all. Thank you so much. Have a wonderful rest of your day, and take care, everybody. Goodbye.